In this video, we're going to talk about a few core programming concepts that are going to set us up to do some really neat things in the future. So we're going to start off here kind of by talking about variables. But before I get to variables, we're going to talk here a little bit about types in programming languages. So types are the specific ways in which the computer, or in this case the Arduino, is storing and representing the specific data that we're asking it to represent. So for our numerical types of data, there's kind of three key ways in which it's represented. So the first is an int, which is used to represent integer or whole numbers, right? So it can represent any positive, negative number, or zero. A float is something that is used to represent our decimal values. So it can represent data after the decimal point. And so the distinction between these two is important because it's reserving certain space in the Arduino's memory to store those values. So we need to keep track of this idea of type to understand how this data is represented and how we actually want to represent it, and if we want to represent the decimal point or not. So that's kind of first here. But Arduino also has these two special values, high and low, that correspond to on and off. And we saw that with digital write, where we use all uppercase high or all uppercase low to turn on or off an LED. So a variable in programming is much like it is in mathematics, right? It's some named symbol that holds a value that can change over time. So up until this point, we've really just used values that we've stored in macros because they've been constants. And macros aren't actually part of the code. They're just kind of a way of renaming a constant throughout and creating an alias that makes sense to us. So a variable is going to be something that's actually part of the program and allows us to store intermediate values until we're ready to use them, and we can modify them and do certain equations and stuff like that. So as we're discussing variables, we're going to kind of talk about three key things. So that's variable declaration, variable assignment, and variable usage. And so declaring a variable means just giving the variable some type, whether it's going to store an integer value or a float value, and then a name. So representing the name of that value, right? So like in math, you use a squared plus b squared equals c squared, right? You're using independent letters. In programming, we're going to be able to use more intuitive names. So that's declaring a variable. We can also assign a variable, which is a way that we update the value that's being stored inside of the variable. And then we can also use the variable, right? So consuming its value and using it in some sort of expression, whether it be like a mathematical expression or something like that. So those are the three key things that we can do with a variable. And so there's kind of two basic rules of using a variable. Is first, we have to declare it. We must give it a specific type to know, so that the Arduino knows how to store that information. So we got to say, hey, it's an int or it's a float. And then we have to initialize it. We should always give it some initial value so that there's not weird, unexpected behavior. So we'll take a little bit of a closer look at that here. So this is a little bit what it looks like down here. This is kind of showing some example code over here with some comments kind of explaining what's going on here on the right-hand side. And so an important thing to know in programming is that an equal sign doesn't actually represent an equal sign. It's something known as the assignment operator, right? So what it does is it assigns whatever is on the right-hand side of the equal sign to the variable that's on the left-hand side. So a variable is the only thing that can be on the left-hand side of an equal sign. And so you can imagine that this is kind of like the top line of code and we're going down sequentially. So this right here is me declaring a variable called x and giving it some type int, but I'm also assigning it some initial value here. So I'm saying define some integer variable x and set it equal to 5. And so from this point forward in the code, x is equal to 5, right? And so here, when I say, okay, define some new integer variable called y and set its initial value equal to 6, now y is equal to 6. So that now when I come down here and it's saying x is equal to x plus 4, what it's going to do is it's going to take that previous value of x right here and substitute it in for the x that's on the right-hand side of the assignment operator. Because remember, it's not an equal sign. It's going to make an assignment and say that this value that I compute on the right-hand side is going to be made equal to the variable on the left-hand side. So we substitute in that 5, we get 5 plus 4, which equals 9. And so now what happens is from this point forward in the code, x is going to be equal 9 x is going to be equal to 9 until we change it again. So on this final line of code here, it's saying x is equal to y plus x. So what it's going to do is it's going to substitute in whatever the most recent value of y was, which is 6. So we get 6 plus whatever the most recent value of x was, which from this last statement here, it was 9. So we get y plus x, which is 9 plus 6, which is equal to 15. So now x is going to be 15 because we're assigning what is on the right-hand side to what is on the left-hand side. So that's kind of the basics of the assignment operator here. Now, I mentioned that we have to do variable declaration and assignment. So this is kind of the syntax of doing that, right? So we always say the type first, and then we say its name, and we only have to declare the variable once. All it's doing is it's setting up a location in the Arduino's memory and saying, hey, this is going to be an integer value. It's only going to be whole numbers, and its name is this. So we just do that once to set it all up, and then it's fine. We can change its value at will later on, as long as we're just storing values that are of that specific type. So I can only store like whole numbers to integers, and for float values, I can store decimal values or whole numbers as well. It doesn't really matter. It just allows us to store a little bit more information after the decimal point. So this is kind of an example of me declaring and assigning two different variables. So I'm saying, okay, declare some variable called counter. It's going to be an integer and it can only hold integers, and set up its initial value here to be equal to 0. So it's assigning what's on the right hand side to the variable on the left hand side. And then here we're saying, okay, create a variable called temp, its type is float, and assign it a value of 0.0. Now, this is what happens if we were to use a variable's value, right? So I kind of showed that in the initial thing, but I really just want to drive the point home, right? So if I had some program that had these 3 lines of code, these first 2 are just me declaring the variable, basically saying its name and its type, and doing some initial assignment, right? There's an assignment operator there, so I'm doing some assignment where I'm taking the right-hand side and assigning it to the left-hand side. So now what it's doing is it's declaring spam as an integer and giving it an initial value of 5, and eggs is an integer and an initial value of 3. So here, when it comes time to do this operation, what it's going to do is substitute in these previous values here, and so it's using those. We would call this variable usage because it's substituting in its previous values into there, but it's also doing an assignment now here. Right, so there's kind of multiple things going on in each of these different steps. So I would substitute in those previous values and do 3 times 4 plus 5. Our like PEMDAS orders of operations still apply here in programming. And so it would be a new value of 17. So, like I mentioned before, the Arduino compiler is great at helping you find errors. It'll tell you where an error occurred. And so here, if I got this error where it says val was not declared in this scope, what I can see here is I declared, some new integer variable called sum, and then I'm trying to set it equal to what's on the right-hand side, which is val plus 7. But I never declared val, meaning I never gave it a type, and I never gave it an initial value, so it has no idea what I'm talking about, and that's what it's complaining about. It's saying val was not declared in this scope. So in order to get rid of this error, I would need to declare val. I would need to say what type it is, and I would need to give it some initial value so that its value could then be used here. And kind of the last thing I want to talk about here is naming of variables, right? So variables, we can have a little bit more intuitive names. I know a lot of those examples I did were just X and Y, right? But you can give it, kind of a fairly lengthy name that is representative of what it is, right? Like I could call it something like sensor value or servo angle or something like that. And so it can be, the rules are, it can be any combination of letters, numbers, and underscores. You can't have spaces in there or else it would get confused about what you're talking about. And it's also important to note that case matters. It can't begin with a number, and it can't be longer than 31 characters, or else it just lops off the end of it, and it would think it's the same as another variable name. So just kind of keep these rules in mind. And then there are some special reserved keywords in the language, in the programming language, that you can't use as a variable name, right? So we just introduced int as a type. I couldn't declare a variable called int because it would think I was referring to the type. So these are words in the programming language that are reserved for special, they have special meaning, right? So we can't use these as variable names, and I don't expect you to memorize all of these. A good tip or trick to kind of run with is if it changes to a different color in your editor, it typically is reserved for some special meaning, right? Because then it's kind of helping indicate what that word means. So just if it changes to a different color, probably just use a different variable name and try to make it a little bit more unique to what you're trying to do there. So yeah, the last thing is just, you want to intelligently name them so that when you're reading your program, you understand what value is being stored in there and what the program is doing. So we can kind of go through a little example here, right? So are these legal or illegal, right? So this first one, it's not that intuitive what it's representing, but it would be legal. It's just a letter. Int would be illegal because that's a reserved keyword. 100s digit, that would be illegal because it starts with a number. This is illegal for the same reason, it starts with a number, but it also has a special character in there, which we can't have. These next two would both be legal. It shows two different ways of trying to break up words within a single variable name to make it a little bit more readable, because if it was all miles per hour, all lowercase, it wouldn't be that legible. So this is something called camel case, where you make the first letter of the first word lowercase, and then the first letter of each subsequent word uppercase to kind of break it up. And you could also do it with underscores. This is more typically done in Python, whereas this is kind of used in all other programming languages. I don't know why, that's just kind of how it is. And then these two would both be legal. This one is actually too long, so it would be recognized as the same as this. For, we haven't talked about this yet, but for is a special keyword that's reserved, so that would be an illegal variable name. For spelt out like the number, that would be legal, but it would be confusing, right? Because I could say the variable for is equal to, the number 67, which wouldn't make a ton of sense. And then break here is another special keyword that wouldn't be able to be used. So this kind of, identifies some of that. But again, don't worry too much about the keywords. If it just changes to a special color in the editor, just go ahead and change it to something else. That's the best rule of thumb there. All right, and then literals are the special term that we use in programming languages where we're talking about some fixed value that's represented in code. So every time I type in some value, we could refer to it as a literal, right?